All right, so in today's lesson, we're going to be talking a little bit about how to graph an exponential function, which really isn't all that bad, but we've got to understand the steps and the orders to know how to do that. So looking up here at our guided notes, we're going to look over a couple things. So the first thing we want to do is point out the objective. At the end of this, we want to be able to identify the types of exponential functions as well as elevate and graph them. And like I said, we're going to worry about the elevating part tomorrow. That's talking about transformations. But today we're going to focus primarily on how to graph them. And this is going to grow into a little bit more to talk about in the coming days. So the first thing that it talks about, it says up here, there are two basic types of exponential functions. There are two basic types of exponential functions. And we kind of briefly talked about those a while back. And those two types of exponential functions are going to be shown up here on the board. Now, the ones we're looking at up here on the board, if you notice, there's a blue graph and a black graph. The blue graph, if I notice, as I move from one side to the other, it's doing what? Increasing or decreasing? Increasing. So the type of graph, it says this type is a blank function. That's going to be an exponential growth. Okay, that's going to be what we call an exponential growth function. And like I said, with exponential growth, we're going to increase. See how these values go up? We're going up, so that's going to increase. All right, so exponential growth simply means we're increasing the values. And then when we look at the other function, we notice that the values are starting over here, and they're going down. So when values decrease, all right, so when we look at this, you can see that these values are going to go down, and they're going to decrease. Then that's what that's the type of function we call a exponential decay. And that's going to be when it's decreasing. So we have two types of functions here. We have an exponential growth function, and then we also have an exponential decay function. With exponential growth, we're increasing our values from left to right. With the exponential decay function, we're decreasing our values from left to right. If you have any questions about this, pause your video and raise your hand, and I'll answer any questions you have. All right, so next we're going to go into the graphing part of exponential equations. So it says in order to graph an exponential function, we first got to make a table, and then we can take the table and get points, and then we can take those points and plot them on a graph, making a smooth curve. So what I'm going to do is I'm actually going to graph my values. Now, the table that they have set up is a little different from the table we're accustomed to using, but that's okay. All they're wanting you to do is put your function in this problem. So like here, our function is identified as 2 to the x power. So with 2 to the x power, we would say that our function is going to be 2 to the x power. So if x is equal to -2, then that means that we're going to take and put a -2 in the exponent here, or substitute in a -2 for the exponent. So that's what it would look like. So to solve that, it's nice if we have a calculator on hand. So if you have a calculator on hand, you can take and then substitute that into your calculator by going 2 and then raising it to the -2 power. So when I get this, if I change it to a decimal, I'm going to find that my decimal value for this is going to be 0.25. So I can actually identify the value. Now, I want to do this for each one of those points. So next, I notice that x is going to be equal to -1. So that's going to be 2 to the -1 power. And then when I substitute that into my calculator, 2 to the -1 power, I'm going to get an answer of 1/2, or 0.5. And I would continue this process. I would take, once again, x is equal to 0. That would be 2 to the 0 power. And then anything to the 0 power is always understood to be 1. Next, I would do 1 So 2 to the first power, we know 2 to the first power is 2. We also know that 2 to the second power is going to be 4. And then the last one here, 2 to the third power is going to be 8. So by using that information, we're able to identify all of our values, and then we can make points from these because we know that our first point is going to be negative 2, 0.25. So we can go ahead and write that out beside it. Negative 2, comma, 0.25. Our next point would be negative 1, comma, 0.5. And then we have 0, 1. We have 1, 2. 2, 4. And then 3, 8. So once we've identified every point, we're now ready to graph. So in order to graph this, all we're going to do, move down here to our graph. And then our graph, we're going to do our best to plot every single point. Now, some of these points are going to be easier than others. The decimals are going to kind of get hard to graph. But we got to keep in mind which numbers those y values are in between. So let's start with negative 2. So first off, we had negative 2 and then 0.25. So that means we're going to come over here on the x-axis and we're going to go 1, 2, and then 0.25 is barely above 0. It's a quarter above 0. So when I think about that in relation between 0 and 1, what I want to do is I actually want to go up just barely above 0. I want to go up a quarter. Now with these type of problems, we're going to be estimating a little bit. So we want to estimate and go ahead and just get it as close as we can, okay? And then the rest of them will make more sense. So the next one would be negative 1. So negative 1, 0.5, we know that's going to be negative 1. So we're going to come over to negative 1, and then we're going to go up a half. And we can put a point. So that one's a little easier to graph. Now after that, we get a little bit easier because our numbers become whole numbers. So after that, we've got 0, 1. So we're going to start here at 0, and then 1 is going to be up here. So we'll go up 1. Next, we would have 1, 2. So that'd be to the right 1 and up 1, 2. We would have 2, 4, which would be to the right 1, 2, and then up 1, 2, 3, 4. And then the last one would be 3, 8. So we would go to the right 1, 2, 3, and then we go up 1, 2, 3, 4, 5, 6, 7, 8. Now we can see a smooth curve forming. So what we would do is start our line out, and we would connect our dots. And then we could just finish it out by putting arrows on both ends, and we would have the graph of our exponential equation. So with graphing exponential equations, we're looking to make a smooth curve, and we have to be able to plot those points. And usually the harder points to graph here are going to be your decimals. Once you get past the decimals, everything else is going to get a little bit easier. So what I want you to do, and if you have any questions, feel free to pause. Go ahead and ask questions about this. But what I want you to look at next is I want you to go ahead and see if you can work the second problem here. Go ahead and see if you can work this on your own. F of x is equal to 4 to the x power. And I'm going to give you a couple minutes. Just pause the video, and then you can, once you finish, you can start it back up. All right, so welcome back. All right, so looking at this problem, you can see that I've already laid it out for you. I've already taken 4 to the x power, and I've went in and I've substituted in all my numbers in for that exponent. So I just substituted each x value in for the exponent. And once I've done that, now I'm ready to solve. So I'm going to take my calculator, and we'll start with the first one, which is 4 to the negative 2 power. So when I type in 4 to the negative 2 power, I'm going to get 1 over 16, or 0.0625. That's a big decimal number. From here, I want to go ahead and do 4 to the negative 1 power. So when I do 4 to the negative 1 power, I'm going to get 1/4, or 0.25. When I substitute in 0, 4 to the 0 power is going to be 1. 4 to the first power is going to be 4. 4 to the second power is going to be 16. And then 4 to the third power is going to be 64. Once I have all that written down, I can then write my points down. So this is going to be -2, comma 0.0625, -1.25, 0, comma 1, 1, comma 4, 2, comma 16, and then lastly 3, comma 64. All right, so when I move down to graph this on the graph below, first thing I'll do is start with my -2. So if you notice, -2 here has a 0.0625. That's really, really close. That's underneath 0.1. So it's basically on 0. It's going to look like it's touching 0 when we graph it, but it's not. It's just slightly above it. So what we're going to do is we'll start here at 0, 0, and go to the left 1, 2, and then we're just going to go barely above. Like I said, it's going to look like it's touching, but we're just going to go barely above -2. We're just going to rise just enough to plot this point. Next, we had -1 and then 0.25. So we're going to go to the left 1, and then we're going to go up 0.25. Now, this will look a little bit higher. Not much, but just a little bit. Next, we have 0, comma 1. So 0, comma 1 means you start at 0, 0 and go up 1. 1, comma 4. 1, comma 4 is going to go to the right 1, and then up 1, 2, 3, 4. And then if you notice when we get to 2, comma 16, we could go right 2, right? We could go to the right 2. But then when we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we run out of space, right? 16 is going to keep going up, right? It's going to keep going on up. So what we've got to do here is plot what we have. So what we can do is we can go ahead and connect these. And then since we know the next number is going to rise really, really fast, we're just going to go straight up with it, okay? We're just going to go up as high as we can with it and kind of estimate where we would be at when we get to that 16. So with this one, we have to be a little bit more careful because since we have such a big base in this one, the bigger the base, the steeper the graph gets. So that's what we got to keep in mind there. The bigger the base is, the steeper, the faster it's going to increase. All right. So then the last problem I want you to look at is I want you to go ahead and see if you can work the last one. We're going to go through it a lot quicker, but see if you can go ahead and work the last problem out, and then we'll come back and we'll talk about 3 times 2 to the x power. All right, so the last part of our notes that we're looking at here, and you can tell I've already went ahead and filled out our table, but what they did is they actually gave you a place where you could put the parentheses 3, and then they also gave you a place to put the 2 to the x power so that you can kind of break it down and solve it. Now, for me, I like to just combine both of them, but if you're one of those people that need to see it worked out separately, you can work it out separately and then multiply your 3 in this case. So you can tell, as I went down through here, I just substituted parentheses 3, parentheses 2, and then I just put whatever power I had, in this case, -2 power. And then when I hit enter, I got an answer of 0.75. And then you can see I did that for all these all the way down and got 1.5, 3, 6, 12, and 24. Essentially, I'm taking what I had over here on my first problem. If you notice here, and I'm just multiplying it times 3. Like 8 times 3 is 24. 4 times 3 is 12. 2 times 3 is 6. 1 times 3 is 3. And you can see how those numbers came about. Because essentially we were dealing with the same function here. 2 to the x power, 2 to the x power. The only difference was the multiplying 3 in the front. Now, once we got our points laid out, once we have everything ready to work out here, we can go ahead and look at the graph of it. So in order to graph this problem, all we're going to do is plot the points that we have. So -2, 0.75, that would be to the left 2, and then up 0.75. It's going to be a little bit higher than normal. -1, 1.5, so that'd be -1, and then up 1 and then a half. 0, 3 would start at 0 and go up 1, 2, 3. 1, 6 would go to the right 1 and then up 1, 2, 3, 4, 5, 6. And then 212 is going to take us off of our graph. So 212 would have been to the right 2 and then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you want to, you could go all the way up and see that it would be somewhere close to there. Now, once we have that information, we can then go ahead and graph. And we connect all of our dots, put arrows on the ends, and we would have a graph of our function.